Hello, it's Mrs. Foltz again. We're talking about the skeletal system still. Today we're going to be talking about the different parts of the bone and getting in a little bit more detail on how we make bone and the different joints found in the body. So let's go ahead and get started. When we're looking at bone, there's three main bone cells we want to talk about: osteoclast, osteoblast, and osteocytes. Now, osteocytes we talked about in the last video because remember those were the mature bone cells that are found inside of the lacunae, which separate the different lamellae or sheets of bone found inside of an osteon. But the other two, osteoblast and osteoclast, we haven't talked too much about. And basically, osteoblast, B for blast, is going to be bone building cells. So these are the cells that are actually going through and building the bone. Osteoclast with a C are going to be the cells in the body that are going to dissolve bone. So remember, we talked about calcium is really stored inside of the bone, and if we need that, we can dissolve the bone. Well, osteoclasts are the ones that do that, okay? These three different bone cells are really important because those bone cells help make sure that our bone is continually being remade. You get a new skeleton every 7 years, so we need to remember that bone is not dead. It's not static. It is continually changing and adapting. Okay, so we have these three different types of bone cells, and I like to kind of think about them like a crew that works on a road. When the road gets to be a little damaged, they kind of clear off and gobble up all the asphalt, and then another machine goes behind it and lays down brand new road. And that's kind of how the osteoblast and osteoclast work. The osteoclast dissolve up the bone and get rid of it, and the osteoblast follow behind and put down new bone. When you're little, when you are a fetus inside of the womb, we actually need to be able to make large amounts of bone at a time. And so what ends up happening for a lot of the long bones in our body is that we start with a kind of cartilage mold, and then these osteoblasts go through and turn that cartilage into bone. This kind of bone formation is known as endochondrial. So in endochondrial ossification, we have a cartilage mold of that bone, and that bone from the middle out is turned into a calcified hard bone from the cartilage. In intramembranous ossification, this is found in like bones of the skull and flat bones. You just have connective tissue, and those cells just differentiate and start to build bone. So two different ways we can build bone in the body: either intramembranous, which is for flat bones like the bones of our skull, or endochondrial. Okay, so intramembranous is going to be for those kind of bones. Also, if you look at the mandible and the clavicle, which we should know where those bone locations are, that's going to be intramembranous. Okay, here's a good picture that kind of goes through endochondrial and kind of shows you what's happening in these different stages. So notice the bone starts as a collar on the outside, and then, like I said, it goes from the inside out. A little bit of cartilage stays in the bone, and we call this the growth plate, kind of up here at the ends of the bone. Once that cartilage is completely gone from that growth plate, you're done growing and you can't get any taller. But until that goes away, there's still some growth that's able to happen. You might remember for our bone diagram, that kind of stays there almost as like a little scar in the bone, and it's called the epiphyseal plate. So last thing we want to talk about today is the different ways that we can classify joints. So joints can be either structurally classified or functionally classified. So structural classification is the joint can be fibrous, cartilaginous, or synovial. We won't spend very much time actually on structural classification. We're going to focus on functional classification of joints. So I want you to know that joints can be immovable, slightly movable, or freely movable. So immovable joints would be things like the sutures that are in your skull. So the sutures that are in my skull, they don't move, they don't go anywhere. Those are immovable joints. Semi-movable joints would be like between the vertebrae in your backbone. So those vertebrae have a little bit of flexibility. They can shift and move just a little bit, but they're not the same as synovial joints. Synovial joints, they have that fluid in there that allows them to have a lot of movement. So probably the one that has the most movement is going to be the number one on our list, which is the ball and socket joint. This is things like your shoulder. You can have a full range of movement with that, or your hip. Other joints don't have quite as much movement. For example, the hinge joint. Hinge joint would be like your elbow. So if you think about your elbow, it can come up towards your shoulder and you can extend your forearm down, but your forearm shouldn't ever bend the opposite way. If you're doing that, there's probably an injury that's happened.